Welcome to solverfy.
This is chapter 27, problem number 4. We have a particle that is accelerated under an external magnetic field, and we are asked to calculate this acceleration. So first, the magnetic force acting on the charge is going to be equal to the amount of charge, the cross product of velocity vector and the magnetic field vector. From Newton's second law, we know that it has to be equal to mass times the acceleration of the particle. So from here, the acceleration of the particle we can retrieve that information by dividing both sides by the mass. So Q V cross product B divided by the mass equals to our acceleration. Now let's take care of this cross product part on a separate place. V cross B, since V is given as 3 times 10 to the power of 4 meters per second J hat, cross product, what we have here is as the magnetic field 1.63 Tesla. This would be the X component I hat plus the Y component of the magnetic field is 0.98 Teslas. You can add the Tesla here, please. And then J hat, which means we're going to have two terms, this times this, and the first term times the second term of the magnetic field. As you remember, J hat cross I hat, which is kind of like the first term, that gives you negative K hat. And for the second term, you have J hat cross J hat. As you know, J hat cross J hat is going to give you 0. So the second term is not going to have any contribution to the force, which means V cross B then is going to be equal to 3 times 10 to the power of 4 meters per second times the X component of the 1.63 of the magnetic field, Tesla, times minus negative K hat. Now we can plug this in the acceleration equation. So then our acceleration is going to be equal to, let's plug in the charge also. That is given to us as 1.22 times 10 to the power of negative 8 coulombs times the V cross B, this entire term here, 3 times 10 to the power of 4 meters per second, 1.63 Tesla, negative K hat, over the mass is given to us as 1.81 times 10 to the power of negative 3 kilograms. So it's going to be equal to 0.33 negative K hat. Of course, the units are meters per second squared.